Good evening, ma'am.
Good evening, ma'am.
Good evening. How are you all?
Fine,
Fine,
ma'am.
ma'am.
Camera. I want the camera. नहीं इसमें लगाना है। चलो चलो। So, hello. How are you all?
Fine, ma'am.
Fine. So, last week, I'm sorry I couldn't take any class. So, are you all lagging in? Like, have you finished kinetics in school?
No, ma'am.
No, ma'am.
Okay. So, we'll start with kinetics today. You have got, all of you have got your marks of the previous chapter. Have you had a test in aldehydes and ketones? No, we didn't do aldehydes and ketones. What is the last topic?
Electrochemistry.
Electrochemistry test, you got the marks. Only Hariharan has not got. All others have got.
Yes, ma'am.
Okay. So maybe tomorrow I will discuss. I haven't gone through your papers as yet, but I will discuss it tomorrow. So chemical kinetics, as the name suggests, kinetics is about the speed of a reaction or a rate of a reaction. Okay. So last year you have learned about thermodynamics, which tells you about the feasibility of a reaction, whether the reaction can take place or cannot take place. So that is about the feasibility of a reaction. Kinetics tells us about the rate of reaction. Now there are different types of reactions that you see around us, different chemical reactions that you see around us. And you will realize that some reactions are very fast reactions. So very fast reactions. Fast reactions, example that I could take is a reaction of sodium chloride and silver nitrate. Okay, so when I mix the two solutions, I get a white precipitate of silver chloride and NaNO3. Now this reaction is so fast that you can, it does it within a fraction of a second, the reaction is over. So when we are talking about fast reactions, it is very difficult to find the rate of such fast reactions because they are extremely fast. They happen in a fraction of a second. So we don't really talk about those. Then we have certain reactions which are very slow reactions. When I say slow, I mean very, very slow reactions. Hmm? Slow reactions like, for example, I take rusting of iron. Okay, so if I take rusting of iron, you keep a iron bar in open moist air. It will take long time for the reaction, for the rust to form. So they are very, very slow reactions. So those reactions also we don't study under chemical kinetics. So basically what I'm saying is that those reactions which are very fast, we don't study. Those reactions which are very slow also we don't study. So then which reactions do we study in kinetics? The reactions that we study in kinetics, they are, why my, this one is not going down. Just 1 minute, children. I will stop share and share again. So we are going to talk about moderate reactions, which are neither fast nor very slow, so that we can measure the rate of those reactions. So we are basically trying to find the rate of reactions which have a moderate speed. Generally, the organic reactions are those for which we can really find out the kinetics of the reaction or the rate of the reaction very easily. For example, esterification that we have learned in alcohols, that acetic acid, ethanoic acid and ethanol, they combine to form ethyl acetate. Such reactions, moderate reactions, we can find out there, we can study the rate of those reactions. Okay, so that is one aspect, that we can't find the rate of reaction of all reactions. We try to study the rate of reactions which have a moderate speed, which can be measured easily. Okay, now there are several terms that we use when we are using the rate of reaction. There are several terms that we use. So when, say for example, the car is moving on a road, right? Then what happens? How do you find the speed of the car? Distance traveled by time, right? So supposing there is a reaction taking place where the reactants A is changing into B. Okay, so this is the reactant and this is the product. B is the product. So how can I measure the rate of reaction? The rate of reaction will be change in concentration of reactant by the time in which the change has taken place, or the change in concentration of the product by time. Okay. Okay, so it could be change in concentration of the reactant by change in or by time, or change in concentration of product by time. So say for example, there is a reaction in which, so I can say rate of reaction will be equal to, will be proportional to, let me say, change in concentration by change in time. I can say equal to what? Rate of reaction is equal to change in concentration by change in time. Now, this reaction that we find out here, I mean, I can write it change in concentration. I can write delta C, change in concentration, upon delta T, change in time. Okay. Now, if I'm talking of change in concentration, I must understand whether I am talking about the change in concentration of reactants or I am talking about change in concentration of the products. So first, let us see in terms of reactants. So if it is change in concentration of reactants, then what will happen? Look at this graph. So there is a graph I will draw here, right? And the reaction is progressing. This is the time T, and this is the concentration C, right? Now, if I'm talking in terms of reactants, let me call it R, concentration of the reactants, that is R. And this is the time. R is concentration of reactants. We are talking in terms of reactants. So when I begin the reaction, say the concentration is, when I begin the reaction, the concentration is here. And as the reaction at time T1, this is the time T1 at which the react concentration is here. This is the time. This is the initial concentration. I call it, say, R1. And this is the time T1. So at time T1, the concentration is R1. Now, as the reaction progresses, what will happen? The concentration of the reactants will increase or will it decrease? It will decrease. Why will it decrease? Because the reactants are being consumed. So slowly the concentration of reactants will decrease. As the time goes, the concentration of the reactant decreases. So here say it was R1. Then after time T2, so this at this point, say the time is T2, then the concentration at that time is R2, right? So what will be the rate of reaction? The rate of reaction will be rate of reaction. I can write will be change in concentration of the reactants. So what is the change in concentration? R2 minus R1. So R2 minus R1 upon T2 minus T1. All right. Now R2 minus R1, I will have to put a negative sign before it. Why will I have to put a negative sign outside? Can someone tell me why should I make it minus R2 by R1? Because R2 is,
Concentration decreases.
because the concentration is decreasing. So the R2 is less than R1, and you cannot have a rate of reaction which we say is a negative rate of reaction. So when we are expressing the rate of reaction in terms of the reactants, then we have to put minus. So rate of reaction in terms of reactants is equal to minus R2 minus R1 upon T2 minus T1. That is the other thing that you should understand here, that unlike the speed of a moving car, if the car is moving by a same speed, the car can move by the same speed, so you can easily find out the speed of the car. But in case of reaction, the concentration continuously changes, and since the concentration continuously changes, the rate of reaction also continuously changes. So the rate of reaction that I found, the rate of reaction at R1 and rate of reaction at T1 and T2, the two rates of reaction are going to be different. So if I try to find the rate of reaction between R1 and R2, okay, between these 2 points, say A and B, if I'm trying to find the rate between A and B, then it is not the same rate, it is the average rate. So what we find by this method is always the average rate of reaction. So why do we call it average rate of reaction? Because the rate of reaction is continuously changing. Why? Because the concentration of the reactants is continuously decreasing. So as the reactants are being consumed, the rate of reaction is directly proportional to the concentration of the reactant. So when the reactant is more, the rate is high. When the concentration is less, the rate is low. So when I find the rate of reaction between 2 points by knowing the difference in concentration and difference in time, what am I trying to find? The average rate of reaction. Now, similarly, if I do it in terms of products, now you see the same graph I am drawing. Here is time t, and this time here I am showing in terms of the product. Now, what will happen? The initial concentration of product is not there at time. When time is t 0, that time the concentration of the product is also 0. Now, so as the time increases, what happens? The concentration of the uh, product increases. Okay, so the concentration of the product slowly increases with time. So here, if I have to find the rate of reaction in terms of A and in between 2 points A and B, so supposing there are 2 points, one point is here A and there is another point here B, right? Then this is the concentration here at time t1, and at this time the concentration is P1, and this is the concentration at time T2, and this is the concentration at that concentration it is P2. At T2, this is the concentration of the product. So what will I write here? The rate of reaction. Let me write it as ROR. ROR in terms of product. Okay, so what will it be? Change in concentration of the product. So P2 minus P1 upon T2 minus T1. Here I don't have to write a minus sign. Why? Because my concentration of product is continuously increasing. But here again, it is the average rate of reaction. So average rate of reaction in terms of the product. So why is it average? Because the concentration of the reactant is decreasing. So the rate at which the product is formed, that also will decrease. And so you cannot have a constant rate of reaction. So in chemistry, the rate of reaction can never be constant. The rate of reaction becomes constant only if the rate is such that it's independent of the concentration of the reactants. There are certain reactions which are not affected by the concentration of the reactant. So in those cases, there will be it will be constant. But otherwise, the rate of reaction always is average rate of reaction. So that is the meaning of average rate of reaction. Now, along with average rate of reaction, there is another term that we should understand is the instantaneous rate of reaction. Instantaneous rate of reaction means at a particular instant, what is the rate of reaction? So if I have my graph once again, right? and this is the graph for the reactants. And I want to know the rate of reaction at this point. At this particular point, I want to know the rate of reaction. So this is known as at this point, whatever is the concentration and whatever is the time, that ratio of the two will give me the instantaneous rate of reaction. But how will I find that? To find that, what will I have to do is I will have to drop a small tangent, right? So I will have to drop a tangent which will touch this, right? And I have to find the, uh, this hypotenuse by, not hypotenuse, the perpendicular by base I can find, and the slope of this point, the slope at this point, that will give me the instantaneous rate of reaction. So if it is for products, you find it like this. If it is for reactants, how do you do it? Now, if it is for reactants, this is temperature. Oh, sorry, temperature, and not temperature, sorry. This is time. This is time, and this is concentration of the products. Reactants, concentration of the reactant. And the same way I can draw another one. This is time, and this is the concentration of the product. And this time the graph will be like this. And at a particular point, if I want to draw, then I have to draw a tangent here, right? And then I can find the slope of this tangent, and that will give me the instantaneous rate of reaction. So what will be the instantaneous rate of reaction, ROR, in terms of reactant? How will I write it? I can call it minus D. D is, delta. So for a very small, this point is where the change is very small. So I can say delta concentration of the reactant. So change in concentration of the reactant. So delta R upon delta T. And here it will be ROR will be equal to delta P upon delta T. Okay, so that is how we find the instantaneous rate of reaction. So let me give you some real examples to understand what I have been trying to tell you. So here, remember, this is a question where from the concentration of butyl chloride at different times, calculate the average rate of reaction. So there is, this is time in seconds, at 0 seconds, 50 seconds. Okay, so this is, and this below is given, what is given is a concentration of butyl chloride, right? So concentration of butyl chloride is given in moles per liter. So you can see you started with 0.1 mole per liter, and slowly the concentration of butyl chloride is decreasing. As the time is increasing, 50 seconds, 100 seconds, 150, and so on. As the time is increasing, the concentration of butyl chloride is decreasing. So now what I have done here is that in this table, I have this data I have transferred to this table. So here it is concentration of butyl chloride in moles per liter. And this is in time. So first one, it is concentration as it is given here. And then after 50 seconds, after time 50 seconds, the change in concentration. So after 50 seconds, what to find the change in concentration? I have written after 50 seconds, concentration of butyl chloride has become 0.095. So 0.095 by change in time, that is 50, you will get 1.9. So what is the rate of reaction that I am finding out? Concentration by time. So rate of reaction is equal to change in concentration divided by change in time. Okay, so I found out here change in concentration, the first two columns here, that these will give me the change in concentration, and these two columns will give me the change in time. And if I take the two, these are the values that I will get. So rate of reaction. Now you can see here the rate of reaction was initially 1.9, 1.7, and slowly the rate of reaction is coming down to 1.4. So it is always the average rate of reaction. So this is what I meant. Why is it that the rate of reaction is average? Because the rate of reaction is continuously going down. It is continuously decreasing. How are we finding the rate of reaction? Change in concentration by change in time. What is the unit? What will be the unit for rate of reaction? The unit for rate of reaction, can anyone tell me? What will be the unit? It will be, unit will be, change in concentration will be in moles per liter. And what will be change in time? Per second. So mole per liter per second is generally the rate of reaction, the unit for rate of reaction. Okay, so that is, now this one I have tried to plot a graph with it. So this is how the graph will look. Okay, so this is the graph. This is the concentration of uh, uh, butyl chloride here. And as the time is changing, you can see the graph. This is the type of graph that I showed you, although there were no readings, but this was the graph. So this is these are the different points. And when I want to find the instantaneous rate, how will I find? I will find the difference between this. So supposing this is A and this is B and this is C. How will I find change in concentration? Change in concentration. So the slope of the graph will be AB by BC. Okay, so AB will tell me change in concentration and BC will tell me change in time. But what I will get here will be the instantaneous rate. So if I want to find an instantaneous rate, take a slope and find the tangent, the slope of the graph at that point by taking AB by BC. If I want to find the average rate, then I find the rate at two different points. So 1 point here and 1 point here, I can take the change in concentration by change in time. I can find out that. So that is about the instantaneous rate of reaction. Did you understand the difference between average rate and instantaneous rate? Now this graph I have taken from your textbook. This graph is from your textbook. Now this graph will make you understand what I was trying to show in two different graphs. This thing is, the textbook shows the two graphs together. So here it is concentration of reactants, and here it is time, you can see. So this graph here, which is a slope, which is like a parabola, this graph here, this graph indicates the change in concentration with time. So here slowly, as the concentration of reactants is decreasing, the rate of reaction also is decreasing with time. And this one here, you can see here, this one, at this point, if you want to find out, then it is the slope is equal to minus dr by dt, and rate of reaction is, in terms of reactant, is minus delta R by delta T. This is R2 minus R1 by T2 minus T1. So these are the two ways you can find out the average rate and instantaneous. Instantaneous rate is again at a particular instant, what is the rate? And average rate is between 2 points, what is the rate? That is the difference between instantaneous rate and average rate of reaction. Here again, there are two graphs. This is for the, tell me what this graph indicates. Sometimes they only give you the graph and you have to understand from the graph. So this graph is of product or of reactant. This graph is of products. Why? Because the concentration is increasing with time. So since the concentration is increasing with time, this graph indicates the change in rate of reaction with time. So as the time increases, the rate of reaction actually is is becoming slower. Why? Because the product is being formed at a slower rate. Why? Because the reactants are decreasing. So this is how, however, the overall concentration of the products is increasing, but the rate at which the products are being formed, that is slowing down. Because here you see in the beginning, the graph is steep and slowly it becomes, it slows down. The reaction, actually, this indicates that the reaction is slowing down. So the first two concepts, did you all understand properly? Tell me. Why do we measure rate of reaction? Why do we call the rate of reaction as average rate of reaction? Tell me. Vaishnavi, why do we call it average rate of reaction? Sanjay, why do we
Ma'am,
call it average? Tell me.
ma'am, because the concentration changes with time.
Because concentration of reactants changes with time, so the rate does not remain constant. It continuously changes as the rate of reaction changes. And what is instantaneous rate of reaction? It is the rate of reaction at a particular instant. Okay. So how do you find instantaneous reaction? By drawing a slope at that particular point, and the slope of that point will tell you the instantaneous rate, and difference in concentration at 2 points, that will tells you the average rate of reaction. Okay. Now let us go a little further. Now we have to learn another form of rate of reaction. So here what we saw was that there was only one reactant. Okay, so if there is only one reactant, the rate of reaction is either in terms of reactant or in terms of products. There is no problem. Supposing you have a reaction where you have supposing there is a reaction where you have H2, no, some other one, Hg plus Cl2, Hg plus Cl2, right? It gives you HgCl2. Okay. So here this is 1, this is 1, and this is also 1. The ratio of the reactants and products, all 1. So since the stoichiometric coefficients are 1, stoichiometric coefficient means what is written before the reactant and before the formula of the product, that is known as stoichiometric coefficient. So everywhere, what is the stoichiometric coefficient? It is 1. So I can express the rate of reaction in terms of Hg. It will be same in terms of Cl2, and it will be the same in terms of HgCl2. However, if I take another reaction, say for example, N2 plus 3H2, giving 2NH3, right? So 1 mole of nitrogen reacts with 3 moles of hydrogen, right? To give 2 moles of ammonia. So now if I give rate of reaction in terms of nitrogen, it will not be, if I just don't understand clearly, I use the term appearance and disappearance. So the rate at which nitrogen disappears. So supposing 1 mole of nitrogen, after some time, 1 mole of I started with 1 mole of nitrogen or maybe some nitrogen. After some time, 1 mole of nitrogen disappeared. Means 1 mole of nitrogen was used. At the same time, after the same time interval, how many moles of hydrogen will be used? 3 moles of hydrogen. And how many moles of ammonia will be produced in the same time? It will be 2 moles of ammonia. So rate of appearance of, disappearance of nitrogen, if it is X moles per liter, then rate of appearance of ammonia will be double, that will be 2 x moles per liter, right? So the rate of appearance of ammonia will be faster than the rate of disappearance of nitrogen. So if we are writing the rate of reaction, then we'll have to do something. So what we'll have to do, what will be the rate in terms of nitrogen? The rate in terms of nitrogen, if I want to write rate of reaction in terms of nitrogen, then I should write rate of disappearance. So rate of disappearance of nitrogen. Disappearance of nitrogen, N2, will be equal to minus delta N2, concentration of N2 by dt, right? So that is rate of disappearance of nitrogen will be minus concentration. Now rate of disappearance of hydrogen will be how much? Rate of disappearance of hydrogen will be, if I write in terms of hydrogen, it should be minus d H2 by dt. But if I want to compare, so this is how many times? So if this is say x moles per liter per second, what will this will be? This will be equal to 3x moles per liter per second, right? Then rate of appearance of NH3, how will I write rate of appearance of NH3? That will be equal to D NH3. Why did I write minus? Because they were the reactants. D NH3, concentration of ammonia divided by dt. That will be 2x moles per liter per second. Okay, so rate of reaction will be, I cannot say the rate of reaction is different. For all of them, the rate of reaction should be the same. So to equalize, or if you write it in terms of nitrogen or hydrogen or ammonia, I should talk of the same rate of reaction. So what do I do? So to do that, to make it equal, I divide all of them by the stoichiometric coefficients. So I can say that the rate, if I want to say the rate, what is the comparison of the rate of reaction in terms of nitrogen to the rate of reaction in terms of hydrogen to the rate of reaction in terms of ammonia? How do I compare them? So I can say to compare them, what I will have to say, I'll have to say that minus dN2 by dt, that is nitrogen, is equal to rate of minus d H2 by dt 1 by 3. Okay, so this is x, so this is 3x, so I'll have to divide it by 3. So if I'm doing it in terms of hydrogen, I will have to divide by 3, the stoichiometric coefficient. So this minus sign I should put outside. Minus. Okay, and this will be equal to 1 by 2 dNH3, concentration of NH3 by dt. Okay, so if there is a general reaction, I will have to make use of the stoichiometric coefficient. So rate of reaction will depend on also the value of the stoichiometric coefficient. So if there is a reaction which I write A plus B is equal to C plus D. Then how will I write the rate of reaction in terms of each one of them? So rate of reaction ROR will be equal to 1 by A into dA by dt, which will be, this is minus, that will be equal to minus 1 by b dB by dt, which will be equal to 1 by c dC by dt, which will be equal to 1 by d by dt. Okay, so if there is a reaction where the stoichiometric coefficients are not seen, then you have to remember that I must divide the rate of reaction, whatever I get, the rate of appearance or disappearance by the stoichiometric coefficient in order to get the rate of reaction. So the rate of reaction, when we decide in terms of each reactant or each product, then I have to divide the rate of appearance and disappearance by the stoichiometric coefficient. Then only it will become equal to rate of reaction. So that is the importance of rate of appearance and rate of disappearance. So rate of appearance and rate of disappearance will be equal to the rate of reaction if it is the stoichiometric coefficient is 1. But if the stoichiometric coefficient is not 1, then rate of reaction is equal to the rate of appearance divided by the stoichiometric coefficient, or rate of appearance divided by the stoichiometric coefficient. Now we'll do a few questions to understand what I mean by this.
Ma'am, can you show the previous slide?
Yeah. So there is a reaction 5Br minus plus BrO3 plus 6H plus giving 3Br2 plus 3H2. So now, how will I write the rate of reaction? The rate of reaction will be equal to, in terms of Br, if I have to write, what will I write? 1 by 5 delta concentration of Br minus by delta T. That will be equal to, in terms of BrO3, what will it be? Delta BrO3 concentration divided by delta T. If I had to write in terms of H plus, what will I write? 1 by 6. These are all reactants, so I have to put a minus sign here. So minus, this also minus, this will also be minus, dH plus by dt. And if I write in terms of Br, what will it be? 1 by 3 Br2 by d and by dt. And this will be 1 by 3 d concentration of H2O by dt. D shows a change, dt, delta. So shall I go to the next one?
Yes, ma'am.
Okay, so now I have this question. Just see the question. Let me increase the font. Okay. Now this is a question which says decomposition of N2O5 in CCl4 at this temperature is studied by monitoring the concentration of N2O5 solution. Then initially the concentration is this. After 184 minutes, it is reduced to this. The reaction takes place according to this equation. Calculate the average rate of reaction in terms of hours, minutes, and seconds. What is the rate of production of NO2 during this? So first we have to find the average rate of reaction. So average rate of reaction we can find only in terms of N2O5. So average rate of reaction, okay, will be equal to change in concentration of N2O5. So that is delta we have to write it as change in concentration of N2O5. So minus, because it is a reactant. So I'll put those things later. So change in concentration of N2O5 divided by delta T, right? Now this is rate of disappearance. Now if I want to make it average rate of reaction, what will I have to do? Divide by the stoichiometric coefficient. What is the stoichiometric coefficient here? 2. So I have to divide by 1 by 2 into 1 by 2. And since it is a reactant, I will have to put a negative sign here. So put all the details here. So what is change in concentration? How will I find the rate of reaction? Minus 1 by 2 into final concentration minus initial concentration. So what is final concentration? 2.33 minus initial concentration was, final is 2.08. So it is 2.08 minus 2.33 divided by time, that is 184 minutes. This is in minutes. Your answer will come in minutes. So if I do that, what do I get? It is this will come in minus. So what will it be in minus? It will be, use your calculator. So 2.33 minus 2.08. 2.3. So I get minus 1 by 2, and inside this it is minus 0.25 divided by 184. So this minus and minus will become plus. So it will become 0.25 into 2 into 184. Okay, so what will that be? Divided by 2 is equal to divided by 184. So it is 6.79 into 10 raised to minus 4. 6.79 into 10 raised to minus 4 minutes. That is, this is all in mole per liter. So mole per liter per minute. That is the answer, in mole per liter per minute. Did you understand? Why did I divide it by 1 by 2? Because if I just take the concentration of N2O5 and change in time, I am finding the rate of disappearance. So to change it into rate of reaction, what will I have to do? I will have to divide it by 1 by 2. Why did I put a negative sign? Because we are using the reactant. Okay. Now the question is, how much? Now you can do this in seconds and you can do it in hours. That you can do without any problem. If I want to do it in seconds, I'll have to multiply minutes by 60. If I have to do in hours, I have to divide 184 by 60. Otherwise, I have to multiply by 60. So you can get those answers. That's no big deal. But now I have to find the rate of production of N2O4. So what is the rate of production of N2O4? So the rate of reaction is equal to, in terms of N2O4, what will it be? 1/4 into change in concentration of NO2 divided by change in time, delta T. Okay, what is the rate I have found out? The rate I have found out is 6.79 into 10 raised to minus 4 is equal to 1/4 into this value. This is what here, rate of production of NO2 is NO2 by T. So here this value, delta NO2 by delta T. Okay, so what will this value, how can I find? Multiply this by 4. Okay, so what will I get? Rate of production of NO2 will be equal to 4 into this value. So what will that come to? 2.72 into 10 raised to minus 3 moles per liter per minute. Did you understand how I converted it into rate of production of NO2? Okay, so you should be very clear what we are doing. Rate of production is same as rate of appearance of NO2. So the rate is different from, can be, if the stoichiometric coefficient is not the same or not 1, then rate of production will be different from rate of reaction. Okay, so what will be the rate of production? 1/4 of rate of reaction in this case, because the stoichiometric coefficient here is 4. You can see this is 4 here. Okay. We'll have to do a few more questions to understand what we are doing. Let me take one more. Has any one of you started doing kinetics in school? Sai
No,
Kalyan,
ma'am.
I don't. Sai Kalyan, are you there?
Yes, miss.
Today I didn't hear you at all. Why you were slightly late?
Network issue, miss. Been 5 minutes late.
So none of you have started kinetics in school. Sai Kalyan, you also have not started kinetics in school?
No, miss. I missed completed.
Completed. Oh, so you are always ahead of the class here. Okay. So did you understand what I am saying? You must be already knowing, isn't it? So
Yes,
now
ma'am.
the next question, Sai Kalyan will help us. For rate of reaction. Now, this is a simple question. How will you do? For reaction R giving P, the concentration of reactant changes from 0.03 m to 0.02 in 25 minutes. Right? Calculate the average rate of reaction using units of time in both minutes and seconds. This is very easy. No, nothing is given. R changing to P, the stoichiometric coefficients are not there. And so the rate of appearance and the rate of reaction and rate of disappearance and rate of reaction is going to be the same. So how will I find the average rate? Now this time, who will do the question for me? So average rate is equal to Vaishnavi. Can you tell me how will I do? Average rate is equal to change in concentration of the concentration of the reactant. So change delta R by delta T. Okay, so what is change in concentration of the reactant? Can you tell me? It is from 0 and
0.02
this will be
minus 0.03.
Yeah, so 0.02 minus 0.03 and there is a minus sign outside, divided by change in time 25 minutes. So it will be 0.101 divided by 25. This answer will be in moles per liter. Answer will be in moles per liter per minute. per minute. So what will that be? 0.01.
4 miss. 4 mole per minute. 4 mole per liter per minute.
4 moles per liter per minute. Will it be 4 or 4 into 10 raised to minus 4? 4 into 10 raised to minus 4 moles
I
per
started
liter.
with 4 into 10 raised to minus 4.
Yeah. So this will be 4 into 10 raised to minus 4 moles per liter per minute. How will you find it in seconds? It will become 0.01 into 25 into 60. Okay. So you have to divide again by 60. So it will be 6.66, 6.67 into 10 raised to minus 6 moles per liter per second. Okay, so that is how you can. Now, in a reaction 2A giving products, the concentration of A decreases from 0.5 to 0.04 moles in 10 minutes. Calculate the rate of reaction during this interval. So here there is a stoichiometric coefficient. So how will I find the average rate? So in this case, average rate of reaction will be equal to how much? Minus 1 by 2 change in concentration of reactant by change in time, right? So what is change in concentration of reactant? 0.4 minus 0.5 divided by 10. So what will that be? 0.1 divided by 20. So what will that be? 0.1 divided by 20, 0.05. 0.1 divided by 20. So that will be 0.005 moles per liter per minute. Okay, are you understanding, all of you? Hariharan,
Yes,
did you
ma'am.
get it? Sura,
Yes, ma'am.
who else? Somebody has left in between. Sanjay, did you understand? Sanjay? Vaishnavi, you understood? Vishal, are you there?
Yes, ma'am.
Vishal?
Understood, ma'am.
Yes, ma'am.
Very good, very good. So did you understand?
No, ma'am. Sanjay, ma'am.
Yes.
Sanjay, are you understanding, Sanjay?
Yes, ma'am.
Okay. Now the next thing, we can do a few of these questions to few of these MCQs to understand this, whatever we have learned till now. For a reaction 2A plus 3B giving 4C plus 5D, the rate of reaction in terms of delta A. What will be the rate of reaction in terms of delta A? Tell me. Who will tell me? Sai Kalyan, tell me. What will be the rate of reaction in terms of delta A? In terms of A, what will be the rate of reaction? Change in concentration. So A, what is the stoichiometric coefficient? Sai Kalyan, are you there?
2 miss.
Yeah, tell me what is the answer for the first one.
I will do instant.
Do it. Whoever finds the answer first, just speak out.
Ma'am, is it minus 1 by 2 del A by del T?
Yes, perfect. Right? Sai Kalyan, did you also get the same?
Yes, miss.
Okay. So that is in terms of A. Now, similarly, you have to do it in terms of delta B.
Ma'am, minus
Hariharan,
1 by 3 del B by del T.
yes, so you got it now. So minus delta B 1 by 3 delta B by delta T. Hariharan, now next answer should be given by Hariharan. For the third question, what is it in terms of delta C? If you
Delta
have
C, ma'am.
in terms of delta C, change in concentration of C, in terms of C, what will be the rate of reaction?
Ma'am, is the answer D, ma'am?
Not D, it is 1 by 4, no? You have to
Oh, 1 by
divide
4.
so, and since it is the product, it will be C,
Yes,
1
ma'am.
by 4, right? Did you understand?
Yes, ma'am. Yes, ma'am.
Sanjay, are you getting correct answers?
Yes,
Sanjay?
ma'am.
Okay. Now let us see the rate of formation of ammonia is 0.345 moles per second. This is rate of formation of ammonia. What is the rate of disappearance of nitrogen? Rate of formation of ammonia is given. What is the rate of disappearance of nitrogen?
Hey,
So rate of
message parra.
disappearance nitrogen should be half of the
Message
rate
parra.
of formation of ammonia, isn't it? Because uh, rate of disappearance of nitrogen, when 2 moles of ammonia are formed, then only 1 mole of nitrogen disappears, right? So if the rate of disappearance of formation of ammonia is this, then what will be the rate of disappearance of nitrogen? Half of that. So what is half of 0.345? That is 0.173.
0.173.
Yeah. Okay. So we can do these questions. I will send them to you. You can answer them. Now this is a graph. These are a few questions which will make your understanding better. Now look at the second one first. Question number 2 you see first. Match the substances correctly to each graph. The chart to the right shows the concentration versus time graph of 3 substances. H2 plus O2 giving 2H2O. Right? So which line is off? You have to just match the graphs. So which line represents the concentration, change in concentration of oxygen, which shows hydrogen and which shows water. Okay. So first thing is the water is the product, right? So if water is, so where should,
That will be O2. Sorry, H2O.
yes, the first one is dashed line is water. Okay, because
நீ பாத்துறேன்டா
this
எப்பா
is increased, right? Now we have to decide which one is oxygen and which one is hydrogen.
நீ வர
So,
சொல்லுப்பா ஜஸ்ட் ஒன்று வருவான்டா அன்னைக்கு இருக்குது அவருக்கு அவன் எப்படி
so
சோமன் ஆடான்னு
the rate of
நான் தானே டீம் கொடுக்குறேன் நான் தானே டீம் கொடுக்குறேன் நான்
appearance,
பாலிடிக்ஸ் பண்றேன்னு சொல்றேன் நான் தானே டீம்
please
கொடுக்கணும்
mute. Somebody is talking. Please
பாத்துக்கோ
mute.
நான் பண்ணுவேன்
Hello. Somebody is.
அவனை பார்க்க சொல்லு
Somebody may have to mute. I don't know who. Sanjay. Sanjay, please. Thank you. Okay. So now I have to decide which one. So here with time, what is the change in the rate of disappearance of the gray line shows rate of disappearance of one reactant. The second one shows the rate of disappearance of the other one. So here
Ma'am, is
hydrogen
gray one O2 and black is H2?
yes, black is H2 because H2 is disappearing much faster than oxygen. So sometimes by looking at the graph, you should be able to see. Now look at the first graph. Assume the scale and units of each graph is same. Which graph does not apply to the reactant? Which graph? This is 1, this is 2, this is 3, and this is 4. So all these
4.
graphs here, 4 does not apply to the reactant. Which graph shows the steepest rate of disappearance of the reactant? Which is the steepest, where the reactant is disappearing very fast? So the first one, the reactant is disappearing much faster. Here it is disappearing slowly. Here you see it is a steep slope. So it shows that the reactant is disappearing very fast. Okay, so this is
Ma'am,
these
so
are a
in
few
the second question, 2H2 plus O2, can we say that H2 is
disappearing much
undergoing
faster.
disappearance?
Yeah, the
Okay.
slope is steeper, so it is disappearing faster. Yes.
Yes.
Okay. Now we have to learn something new. Okay. So the next thing that we need to learn now is the factors on which the rate of reaction depends. So factors affecting rate of reaction. Okay, we will just name the factors and then we will learn each one in detail. So first factor which comes to your mind which affects the rate of reaction. Each one of you say one factor. So Sanjay, what factor affects the rate of reaction? In all these things that we learned just now, we were talking of which factor which was affecting the rate of reaction. Tell me. I told you the average rate, slowly the rate is coming down. Why is the rate of reaction slowing down? Because the rate of reaction depends on the directly proportional to the concentration of the reactants. Okay, so rate of reaction is mainly the factor which affects the rate of reaction is the concentration of the reactant. That is one. The second thing which affects the rate of reaction is the temperature. Okay. The third thing which can affect the rate of reaction is a catalyst. Okay, a catalyst may also affect the rate of reaction. Then the next thing that affects the rate of reaction there are some other things also like, whether the reactant, what is the surface area of the reactant, whether the surface area means whether the reactant the chunks are larger or it is powdered. So all those things also, but the three main factors which affect the rate of reaction are temperature, concentration, and presence of a catalyst can affect the rate of reaction tremendously. So let us first look at how the concentration. So how the concentration affects the rate of reaction. Okay. So supposing there is a reaction where A plus B combine to give products. Okay. I am not writing the products because the rate of reaction mainly depends on the concentration of the reactant. So I can say the rate is proportional to the concentration of A into the concentration of B. Okay, I can say the square bracket shows that the concentration is expressed in moles per liter. When you write something in a square bracket, you mean that you are showing the concentration in moles per liter. So rate of reaction is proportional to the concentration of A and the concentration of B. There is no problem. I can say to remove the proportionality sign, I can say rate is equal to K A into B. Concentration of A into concentration of B. What is K? K is known as a constant, which is known as a rate constant. And rate constant is fixed for a particular reaction for a particular temperature. So rate constant is a constant. Obviously, a name suggests it's a constant and it remains constant for a particular reaction. So that is rate constant. Now, if I ask you to define a rate constant, what is a rate constant? So rate constant is equal to, so if the concentration of A is equal to 1 mole per liter and concentration of B is also equal to 1 mole per liter, then R will be equal to K. So rate of reaction will be equal to the rate constant. So what is the rate of reaction? The rate of reaction is, what is the rate constant? The rate constant is equal to the rate of reaction when the concentration of the reactants of each reactant is 1 mole per liter. So if the concentration of each reactant is 1 mole per liter, then the rate of reaction is equal to the rate constant of that reaction. And there's a particular fixed rate constant for each reaction. So if I keep changing the concentration of reactants, it doesn't matter. The rate of reaction will remain the same. Rate constant of the reaction will remain the same. The rate may change, but the rate constant will remain the same. So you can, now what I wrote here, this is known as the rate law also. It is also known as a rate law. Now, what is very important in the rate law is that the concentration term should be raised to a certain number, and that number may or may not be equal to the stoichiometric coefficient. Now, here it was a simple reaction where the stoichiometric coefficient of A and the stoichiometric coefficient of B was also equal to 1, and I assumed that this is the rate of reaction. But this may not be always the case, because the rate of reaction is something which is always determined experimentally. What is very important in this chapter is that all values are not what you see experimentally. It is very important, experimental value. So we have to depend on experiment values. So, so say for example, there was a reaction in which when I changed the concentration of A, the rate of reaction became double. And when I changed the concentration of B, the rate of reaction did not change. Okay, so that effect I can show properly in a rate law. So supposing I say there is a reaction A plus B giving reactant, giving products. Okay. Now in this reaction, experimentally it was found that when I change the concentration of A, the rate of reaction becomes double. But when I change the concentration of B, then there is no change in rate of reaction. So how will I write the rate of reaction? I can write then K A raised to 2. It becomes double, and B raised to 0. Okay. So what is 2 and 0? 2 and 0 are the order of reaction. Order of reaction. Okay. So 2 is order of reaction. So 2 is equal to order of reaction with respect to, WRT is with respect to A. And what is 0? Order of reaction with respect to B. Okay, so when I see such an equation, what the intimation it gives me? It gives me an intimation that this reaction has two reactants A and B. However, the rate of reaction depends on only the concentration of A, but not on the concentration of B. So rate becomes, when I change the concentration of A, the rate will become double. But when I change the concentration of B, the rate will not change. Okay, so this we can find experimentally and express it in the rate law. So in a rate law, what do we write? In a rate law, we show the rate constant into the concentration of the reactants raised to a power which is determined experimentally. This power need not be a integer, it can be a fraction also, because it depends on, obviously it depends on. So here also let me give you a simple question. That there is a reaction R where the rate is equal to K, A raised to 1 by 2 and B raised to 3 by 2. So what is the order of reaction? Overall order of reaction will be equal to 1 by 2 plus 3 by 2. So overall order of reaction will be equal to 2. Because overall the order of reaction will be 2. So it is the second order reaction. With respect to A, it is 1 by 2. With respect to B, it is 3 by 2. So total order of reaction will be 1 by 2 plus 3 by 2, that is equal to 2. So if I write it in a general way, what is the rate law? How can I write a rate law? How can I express a rate law? Rate law is expressed in terms of rate of reaction, which is equal to rate constant of that reaction into the concentration of the reactants A raised to X and B raised to Y. Okay. Overall order of reaction will be equal to what? X plus Y. Okay, overall order of reaction is equal to X plus Y. So, there is a little more that I will explain here in terms of K. So what is K? What will K be equal to if I am calculating K? K will be equal to R concentration of A upon concentration of B. Supposing there's a reaction where the order of reaction is 1 with respect to A and 1 with respect to B, then what will be the overall order of reaction? I'm talking of this reaction, A plus B giving products. Okay, and R is equal to K, A into B. So when I don't write anything here, that means it is 1 plus 1. So overall order will be equal to 1 plus 1, that is equal to 2. So how will I find the value of K? Find the rate divided by concentration of A and concentration of B. So what will be the unit? Unit for rate is mole per liter per second. What will be the unit of A, concentration of A? Moles per liter, right? And what will be the concentration of B? Moles per liter. Okay, so if I cancel, what will be the unit of K for a second order reaction? What will be the unit of A? It will be this and this will get cancelled. So it will be mole minus 1 liter and second minus 1. Okay. In an order reaction, it will be mole minus 1 liter and second minus 1. So there is an easy way to find out. The easy way of finding is that the rate of the unit of K can tell me what is the order of the reaction. How? Because the unit of K, if you write mole per liter by second, raised to 1 minus n, where n is equal to order of reaction. Right? So, what will be the unit of first order reaction? Unit of first order reaction. Okay, this is a mistake I'm doing. Unit for K will be always moles per liter, 1 minus n and second minus 1. Okay, so for the first order reaction, what will be the unit of K? Unit of K will be equal to mole per liter, 1 minus 1, second minus 1. So this will be 0. So the unit will be second minus 1 for first order. For second order reaction, what will it be? Second order reaction, it will be K will be equal to mole per liter, 1 minus 2, second minus 1. So what will it become? It is minus 1. So it will become liter mole minus 1 liter and second minus 1. So if you know the unit of K, you can find out the order of the reaction. So that is the next type of question I want to make you do it here. Okay, so this is a question. Identify the reaction order from the following rate constant. What is the overall order of following reactions we have to find? Okay, so how will I do? K is given as this value. Now you just have to bother about the unit. What is the unit? Liter mole minus 1 second minus 1. So what is the order of this reaction? It has to be second order. Okay, how did I understand second order? For second order, what is it? Mole per liter, 1 minus n and s minus 1. So s minus 1 remains, but 1 minus 2. So what will it be for second order? Mole per liter, 1 minus 2, second minus 1. So that will be what? Mole per liter minus 1 and second minus 1. So that is mole per liter minus 1 and second minus 1. So it is a second order. Now the second one, what is the unit? Second minus 1. So when is it second minus 1? Mole per liter, 1 minus n, s minus 1. So if value of n is 1, then what will it become? Mole per liter raised to 0, second minus 1. So what type of reaction in this one is? This is the first order reaction. Okay, so this is also a question which is asked in MCQs. So answer here is, this is second order and this is first order reaction. Okay, if it was a third order reaction, what would be the unit? Let us do one more. If it is a third order reaction, what will be the unit for third order? Third order. So for third order, n is equal to 3. So what will be the unit of K? Mole per liter, 1 minus 3 s minus 1. So what will that be? Mole per liter raised to minus 2 and second minus 1. How will I write it? L square mole minus 2 and s minus 1. that will be the unit of third order reaction. So sometimes only based on unit you have to decide the order of reaction. Then there are a lot of questions which you may have to write, understand properly that the stoichiometric coefficients written in a balanced equation are not the order. They don't decide the order. Order is always decided experimentally. So if in a reaction, if it is written like this, R is equal to K, A raised to 2 and B raised to 1 and C raised to also 1. What is the order of reaction? Identify by overall order. So overall order of reaction will be 2 plus 1 plus 1, that is equal to 4. If R is equal to K, A raised to 2, A raised to 1, B raised to 1 and C raised to 0, then what is the order of reaction? Order of reaction will be 1 plus 1 plus 0, that is equal to 2. So from the rate law only you can decide the order of reaction. You can't decide the order of the reaction by looking at the balanced chemical equation. So there may be a equation where 2A plus 3B is giving products. Okay, what I'm trying to say is this 2 and 3 have nothing to do. You have to decide the rate law will be K, A raised to 1 and B raised to 2. For this reaction, the order of reaction, this may be the rate law. The rate law does not depend on this. The rate law is not K, A raised to 2 and B raised to 3. Okay, this is not the rate law, right? This is law of mass action, which does not hold true for finding the rate of reaction. So what is the order of reaction here? Order will be equal to 1 plus 2, that is equal to 3. That is how
Ma'am,
you...
Ma'am, but
tell me.
how do we say that the concentration, concentration of A bar 1 and concentration of B bar 2? So,
That value will be given to you. That will be the experimental determination. So that you will be told that experimentally it is found that the rate of reaction, if it says experimentally it is found that the rate of reaction does not depend on the concentration of A, then it will be A raised to 0. If it says that the rate becomes double when you change the rate of reaction, when you double the concentration of A, the rate of reaction becomes double. So there are three possibilities. First, there is, A changing to products. Okay, so there are three possibilities. Experimentally, the first condition is that the rate of reaction does not depend on concentration of A. How will you write? R is equal to K A raised to 0. What does it show? It does not depend on the rate of reaction, does not depend on the concentration of A. So if I change the concentration of A, the rate of reaction does not change. So the second possibility, so this is A. The second possibility is if I double the concentration of A, the rate of reaction also becomes double. So the rate of reaction changes at the same rate as the rate of change in concentration. So R, how will I write? R is equal to K A raised to 1. That means when I change A, if I double the A, rate also becomes double. If I triple the A, rate also becomes triple. The third condition is where the rate of reaction, when I double the concentration of A, then the rate of reaction becomes 4 times. Okay, then how will I write? K is A raised to 2, A squared. So when I double the concentration, the rate becomes 2 squared, that is 4. So if I double the concentration of A, the rate will become 4 times. So if it is becoming 4 times, how do I express in terms of order of reaction? R is equal to K raised to 2. If it is becoming, if I double, this is also becoming double, then A raised to 1. If it is not changing, then it is like this. So there is one graph, if I think, if I have kept it. Yeah. Okay. So this is zero order, first order, and second order reaction. So in case of first order, zero order, what does it mean? Rate does not depend on concentration. Here, rate changes same as change in concentration. And here, when I double the concentration, the rate becomes 4 times. Okay. So the first one, the rate is 0.4. The concentration of A is 1. Then the rate is 0.2. What does it mean? When I change the concentration to 2, what happens to the rate?
Ma'am, in
It
case of
remains,
first one, will it be 0.20 itself?
it will not change, so it will be 0.20 itself. So 0.20, 0.20, 0.20 does not change. Now here, when I make it double, the rate will also become double, so it will become 0.40. If I make it 3 times, what will it become? 0.60. I make it 4 times, it will become 0.80. Okay? So this is the first order. Now if I say rate is A raised to 2, second order, what do I understand? If it is 1, it is 0.20. If it is 2, it becomes 0.40, it becomes double. It becomes 3, then it becomes 0.3 times, 2 raised to 3. So 0.20 into 0.20 into point. So it will become 0.09.
0.008.
No, point not like that. This becomes double into 2, right? This becomes into 2. This becomes 2 into 0.2 into 0.2 into 0.2. Okay, so 0.8. This will become 0.80. And this will become 1.6.
Ma'am, it will be like 0.20 power 3 only, no ma'am?
Yeah, 0.20 power 3.
Ma'am, then will it not be 0.008? Because 0.2 into 0.2 into 0.2, 3 decimals.
No, I am not multiplying, it is not like that. See, how is the rate becoming double? It is becoming 0.2 into 2, right? Here, here what did I do? This into 0.2, 0.4. Here this into 0.3. Here this 0.2 into 4. It became 4 times. Here it has to become double first. When I doubled, it became double. But when I make it, when I made it 3, it will become 3 times. It will be double and double of that. How do I explain it? There's another way of doing it. Let me show you. Anyway, I cannot make it points. See, if I multiply it 2 raised to this raised 0.2 raised to 2. What is it? 0.2 into 0.2. It is not 0.04. Right? I can't write it as 0.04. How do I express it? It is 2 raised to, how do I explain this part? See, if I make the rate, as you are saying, 0.04, that the rate is becoming less, it is not becoming less. It is so many times. So double of 0.2, this is 4 times of 0.2, and this is 8 times of 0.2, 8 times. Okay, so the rate here, it becomes twice of this rate. Here it becomes 4 times of this rate, and here it is becoming 8 times of this rate. That is why I wrote 0.4, 0.8, and 1.6. Okay, so then it becomes the second order reaction. There are other ways of explaining this. See, look at this one. Probably you will understand better. Okay, so here if you see, you have to find the order of reaction. So what is the order of reaction here? First, this was the concentration, it was 0.5. When I doubled the concentration, it became 4 times of 0.5, right? When I doubled, this became 4 times. So what is the order of reaction? It is second order. R is equal to K A raised to 2, right? Here there is no, I change the concentration, there is no change in rate. So this is K A raised to 0. Here you see, first when I double, this also became double. When I make double of this, this also became double of this. So what is the rate of K? Is A raised to 1. Vaishnavi, did you understand now?
Yes, ma'am.
Okay, so that is how we will do a few more questions. Now we have to do questions of when I change the rate of 2 of them, how will the rate, there are 2 reactants, how will the change be affected by changing the concentration of 2 reactants? So that we'll do in the next class tomorrow. Okay, so see you all.
Thank you, ma'am.
Thank you, ma'am.
Bye.
Thank you, ma'am. Bye,
See
ma'am.
you tomorrow. Sorry, I
Yes.
didn't take class last week. This week I'll have a class on Saturday also. And then
Yes, ma'am.
next week, one more class to compensate. Okay, bye.
Yes, ma'am. Yes, ma'am.
Thank you, ma'am.
Thank you, ma'am. Bye, ma'am.